Being able to make your own dowels and having the ends exposed with the same wood that you're making your project out of is a great benefit compared to just buying any old dowel off the shelf.
There's no one else that makes a machine that creates perfect dowels.
The products out there are plates that have holes in them and you have to pound wood through, but we saw room for improvement for that.
We had other ideas.
So we set out to make a dowel maker. We first started off with like a plate like this, to where you could start really big and work your way down to the sizes. But it's pretty difficult. You kind of need a press for that.
Mike is a great mastermind. He envisions what it should look like.
So this is the first design so far, first prototype. That's kind of where we're at right now. I first started drafting the overall shape and geometry of the dowel press in SolidWorks. I started off with the Acme rod and eventually realized that I needed a way to stabilize the Acme rod, which is where the guide rods came into play. They actually serve two purposes. It holds the tension between the dowel getting pushed through the slug, and it also serves as a guide for the Acme rod while keeping it centered at the same time. So our machinist has got a couple parts done already. As you can see, these are beefy. They're really, really hefty. You can have your Acme rod that goes through here, and that's about all we have so far. After I had a draft that I was happy with, and it was time for the first prototype, Alex machined all the components. From there led into our rigorous testing procedure.
When I first created the first prototype, I was very anxious trying to use it.
What I want to see is going to start mushrooming outwards, so that'll show that we're getting a good cut.
One of the coolest features was a fall-away guide center, and once this pusher reaches this point here, it ramps down on this slope feature, presses down, compresses the springs, and is able to finish the rest of the dowel. So you come up with a perfectly round dowel every single time.
We've been at this all day. No, for the past 5 hours we've been running on this. So now we're down to the last plate where our smallest diameters are at. We're at the final dowel hole. 5 millimeters, right on the dot. It's nice. That's it.
That's the money
Final
maker.
test. Here you go.
Product development is a process. It takes a lot of testing, redesigning. We wanted to have one complete tool to where you could start off with almost any size shape. It sparked our idea of using multiple plates.
The dowel plate had various holes or various dowel diameters. The dowel plate seemed too bulky, and from there we took that and we decided to go through the bushings. We'll be testing our newly designed dowel slug, which would be replacing the traditional dowel plate, which was in our original design.
So the advantage of many different slugs, to where we could come up with all the sizes here, is the flexibility of you make different sized dowels.
Right here we were able to install it. You got your finger grooves, take it out, the new one in, slides right in, easy as pie.
You could replace them if they're ever lost. You could just buy just a single one, then the whole plate. The bushing seemed to be the best way to go.
In the program, could you round out that corner right there?
It was a collaborative process to come up with what worked and what didn't work through testing.
So make sure you go in there. Well, it doesn't have to be an end all, although I prefer it.
You know, I see myself as the tech, trying to debug things. I see myself as trying to solve the problems, getting my hands dirty, and I love getting my hands dirty.
Other thing I've seen is my hand's getting worn out by this. So if you're constantly pivoting it or holding it like this, you're gonna get a blister.
We didn't have a good idea on how to create a good crank arm. So when we first designed it, it just looked like, it was just like a bar, like from a press. And so we had to change it up a bit. The idea came to me with the crank arm. I liked the mountain bike, and it came down to me being on the trail and my front chain ring broke. And I started studying it more, understanding it, and I noticed that it was all aluminum, and then I was like, wow, I could introduce that into the dowel press. Brought it up to Mike. From there, we designed it and brought it to life and started testing it out.
Still going, it's going smooth. You don't even feel it.
This isn't your typical crank arm. It's made out of aircraft aluminum, so it's very rigid, it's strong.
But the length that we have out here, you have enough torque that you don't even feel like there's much effort on here.
There's many different design features in this, kind of hidden away.
As you look right here, you might think it's just a regular cheap piece of plastic, but it isn't.
I feel like this is having a fever right now.
There's a lot of heat buildup that we've noticed in our previous prototypes, and the way we solved that without putting grease on there, because grease and wood's not a good idea, was going with a graphite impregnated Delrin custom machined nut. Cut down on the heat, cut down on the noise, and it made for a long-lasting solution to our dowel press. The journey in developing the dowel press was eye-opening. We wanted to make sure and create a product that, as every other Woodpeckers tool, can be passed down from generation to generation. And I think we've definitely reached that with the dowel press, with this robust design.
Being hands-on with this tool, testing it out, creating dowels, that's the best part about my job. I'm proud of this tool, happy with the end results, and woodworkers are going to love it.